Most mass market SAT prep companies literally teach students to skip questions. In other words, they teach students to recognize the types of questions that students should never answer on an SAT. And the idea is that those questions are supposed to be either too hard or too complicated for students to reliably be able to solve, so you're better off not even trying. You're better off giving up before you even start. So after taking the tuition money, they literally sit you down and they teach you to not answer questions. Obviously, I think that's ridiculous, and in today's video, I'm going to show you how to answer specific questions that other companies, other mass market companies have told students of mine to skip, and I'm going to show you how those questions can be solved using a few simple steps of algebra. In this video, I'm only going to talk about math, but the same applies to reading and grammar. In fact, there is no reason, if you have the right kind of training, that you will ever need to skip an SAT question. The first problem we're doing is out of the official SAT Study Guide, 2nd edition. This particular problem that we're going to start with is on page 919, number 16. Several companies in this area have told their students not to answer this type of question, and I'm now going to show you how you answer this question. Here's the question says. You can take a look at that. It says if xy equals 7 and x minus y equals 5, find x squared y minus xy squared. Now, the reason obviously that many companies tell their students not to answer this question is not because there's no method that works, it's just that their specific methods that they use, like plug-in and back-solve and process of elimination, all that kind of nonsense, doesn't work on this question. Now, in your school math classes, just as a side note, here's how you do this at school. You would solve maybe this equation, and you would say x equals 5 plus y, and then you would plug that in for x, and you get 5 plus y times y equals 7. And then you would solve this, so it would be a quadratic equation. You would solve that for y, and then you'd solve it for x, and that'll work. But I'm going to show you a little bit of a more elegant solution. So we're going to start off with this. We're going to notice that they're asking us this very specific question. So we're going to think about why would they ask this question and not some other question. Why are they asking this instead of, x to the third times y? Or why don't they just ask us just for x or just for y? Now they're asking us this question for a very specific reason. But here's what you do. Go ahead and factor this binomial here, and you factor out an xy, and on the inside you get x minus y. And you know that xy equals 7 because that's given. And you also know that x minus y equals 5, and that's 5. And then you know that 7 times 5 equals 35. And you see that this problem can be basically solved in 3 steps, and I'm including in one of those steps actually writing the problem down. So it's really more like 2.5 steps. So this is a 919 question number 16. We can see how we can solve that in basically 2.5 steps. The next question we're going to do is on the same page, 919, number 14. Now, some of the area companies over here have actually told students to try this question, but instead of actually solving the question in some kind of a systematic, reliable way, they just tell students to just guess a bunch of numbers until you finally get something. Like what you did before you took Algebra 1 when you were in 5th grade or 6th grade or 7th grade or whatever. Before you learned Algebra 1 or pre-algebra, you just kind of guess some numbers, and that's what they want you to do here. Here's the question says. It says, if n and p are integers greater than 1, and if p is a factor of both n plus 3 and n plus 10, what is the value of p? So we know that p is a factor of n plus 3, and it's also a factor of n plus 10. All right, sorry about my writing. My writing's not the neatest. The reverse of that is obviously that both n plus 3 and n plus 10 are multiples of p. Now, what do you know about multiples? Let's, for example, look at multiples of 6. If you look at multiples of 6, you get 6, 12, 18, 24, and you realize that they're exactly 6 units apart. So we know that multiples of 6 are 6 units apart. And also multiples of 7 are 7 units apart. And multiples of 8 are 8 units apart. Now in this case, we're talking about n plus 3 and n plus 10. Let's see how far apart they are on a number line. So I can put n plus 3 over here. I can put n plus 10 over here. And if you look at the distance between them, it is 7 units. They're 7 units apart. So if they're both multiples of the same number, that number has to be 7. These are both multiples of 7, and the way we can tell that is because they're 7 units apart. Now this is a little bit more of a complicated idea. The last one was just factoring. That's pretty basic. This is a more subtle idea. You know, obviously in our vohra method SAT classes, you don't just learn this as one step. You actually go through an entire system where you learn how to think like this. But this is just an illustration of what type of material you can learn when you're going through a more rigorous and more intensive SAT training than what you might get from a company that only talks about test-taking strategies. For the next one, let's actually do the third one on this page, and we'll go to look at some other questions soon. Number 15, it says, in the cube shown above, points B, C, and E are midpoints of 3 of the edges. Which of the following angles has the least measure? This is at page 919, number 15. And if you can't see that, you know, just follow along with your book at home. Hopefully you have, if you're getting ready for the SAT, hopefully you have this book, because this is the most important book for the SAT. What we're going to do here, we're just going to look at some simple patterns. This is X, and this is Y. And what I'm going to do is I'm going to put A and B over where they should go. B would be over here, and A is over here. And we realize that XBY and XAY would look like that. And we can see that XAY is the smaller angle than XBY. And we also notice that, you know, A is farther away from Y than B is. B is a little bit closer, A is farther. And we kind of notice that the farther away the point is, the smaller the angle is. So the question just becomes finding which of these line segments is the biggest. And, you know, if we draw what the base of this would look like, the base of this cube, and we can put, you know, Y over here, and then A would be, B would be here, and then A would be here, and then C would be here, and D would be here, and E would be here. And we look at all these line segments, we realize that D is the longest because it's the hypotenuse of this triangle. It has the longest legs. So that's a question that's more just like kind of a visual, spatial, figuring out a pattern type of question. But again, we see it's completely doable in a very systematic way. There's no need for process of elimination. There's no need to guess. There's no need to use backsolve or plug-in or really anything like that.